Hey, it's Richard. In this video, we're going to go over a few quick Houston architecture type things. Just whatever I can remember and whatever is fairly straightforward to explain. So, I guess the first thing that's important is um, how a command is actually represented. So, you can see this in, I guess I gotta run this, the actual command entry or scheduling area. Each command has an ID, which is here, and this is unique to each command. And that is how, let's say we've got a list of a bunch of commands. The ID is how we pull out a specific one if we want to delete it, for example. So it's a unique identifier. The command also has the actual command, and this is just a string that the satellite takes. Similarly, we have the expected response, again, just a string. Right now, what we do is we take a look at, so every time a new line of data comes in from the satellite, we run that against the expected responses for any commands that have not already either timed out or have not already correctly been acknowledged. So right now it's a very simple comparison. We're not doing anything fancy. We can't say, I want to match some start of a string but then pull data out because I'm not sure what the data would actually be. We can't do anything complicated like that yet, although we're going to need to in the future for sure. The epoch is the satellite epoch to send the command. So this is going to change a little bit as well. So right now, whenever we click uplink, the epoch gets set to 0. So you can consider the number here as the time in seconds after we click uplink that this command will actually be sent. What this will be in the future, if we're like, this is sort of for more of a testing scenario where once I send a command, I may want to run it in the future, but I'm not going to wait around for a really long time. And this is essentially just so that we can sequence things to create tests and stuff like that. So where we may send a command to set something, like set the state, and then we may, a couple seconds after, issue another command to get the state and then check that the state change is correct. And that's why we need to be able to delay transmission of commands to the satellite. And that's what the epoch does right now. In the future, we're going to be able to use the relative checkbox to say either the epoch is relative to when we click uplink, or the epoch, if this is not checked, is absolute. So this is the actual absolute time on the satellite from the real-time clock. And to do this, we're going to need to actually sync the time between Houston and the satellite by grabbing the time from the satellite before we actually calculate this stuff. So let's say we're actually planning a mission in space. We would want to do absolute time so that it's running not just at some point after we uplink, it's running at some time, some real single absolute time in the future. So anyway, those are a few of the fields in a command. So let's take a look at the command class in command.py. So really we just have a member for each one, and then we have a couple other ones. So we have the state. This is the state of the command. and there are 4 of them. So new means we haven't sent it to the satellite yet. Pending means we've sent it to the satellite and we're waiting for a response. Acknowledged means we've received a correct response from the satellite. And errored means it could be that we received an incorrect response, or it could mean the command timed out, so we didn't receive anything in time. The command class does a bunch of handling for default values and getting rid of weird values. So if you just click add to schedule with nothing entered, it will still add commands, just a default one, default acknowledge command. Also, if you do things like enter a string for the time, it will print and then it'll set it to an actual numeric time for you. And then the last important part is the command dictionary. So in Python, you can return a dictionary representation of every attribute in a class. So we've got our command ID, command epoch, timeout, all that, which are just numbers and strings. And we can return a dictionary of all these, where the key is the name and the value is whatever the value happens to be. And we do this and we wrap it just so it's a bit, nicer to use. And we use this because in Kivy, the recycle views are how we show all the data. So like the various lists of commands and stuff. The recycle views take in the data that a recycle view is built from is a list of dictionaries. So this is a way of getting our command and representing it as a dictionary. And then we just create various lists of these so that we can display them on the screen. And Kivy will pull out the various values in each row and print them out. So that's why we need to do that. Let's see, what's another architecture thing? So that's how a command works. I guess the SAT test class. So the SAT test class is instantiated at a global level, and it contains basically the state of the test at any point in time. And what that looks like is a description of whether the commands, so the state of every command. So we have each command in a particular list for new, pending, acknowledged, and errored. And that's so that we can move a command through the various lists as we send it out, as we receive a value or a response for it, or if we happen to time it out. This class also manages checking every piece of telemetry that comes in from the satellite against the expected values to see if we have an acknowledged command. And that's why we need to keep track of whether we've acknowledged each command or not. And then the last thing we can do is attach and update dependents. So what these are they are classes that depend on the data in SAT test. So it could conceivably be multiple things in the future, but right now the only thing that depends on the data, or I guess the results of the data, and is only reading from SAT test and not writing stuff to it, is the response tab. So I'll schedule some, and then we'll take a look at that. So the response tab. So this has to receive the various lists of commands so that we can print them out in different colors to say whether they've been acknowledged or not. So attaching a dependent class to SAT test, what will happen is every time we change the data in one of our lists here, so let's say we move a command from pending to acknowledged, we will call the update dependence function, and then that will call the update from SAT test function in our dependent classes. So if we go into response tab, every time SAT test changes, we actually just grab a handle to SAT test, and then we can go take a look and poke around inside the data in SAT test so that we can update the views on the screen. So this is pretty important to know how those link up. And right now, a dependent essentially is just going to read from SAT test, from the SAT test class. It's not going to add data to it. That's already handled. And that's handled at the top level, generally. Yeah, handled at the top level. And yeah, anyway, there are a few methods for doing that, for like adding, where we lay out a command in the GUI and then we add it to SAT test once we click uplink is when that gets done. So that's how that goes. I think one more thing would be, I guess one more thing in SAT test is uplinking. So uplink gets called for each command when its particular epoch comes up. And this is handled by the Kiwi clock module. So what we say is when we create a command, or when we click the uplink button, we say we will run the uplink function for that command ID at some point in time in the future, which is the epoch for the command. And so when we uplink a command, we add it to our pending list, we remove it from the new list, we send it, or we just print some stuff, and then we actually send it to the satellite. And then, as we've been talking about, we now need to update the dependence because the command is now off of the new list and on to the pending list. And so in this case, in the response tab, it would be turning blue from yellow. So that's how uplinking works. And what it boils down to is just appending the command string. So just that field in the command class. We stick it on the transmit queue, and that makes its way back to the top class and gets sent out from another thread that's handling all the serial communication. So I think that's it for structure of Houston.